Timeline Analysis 1. In this lecture, we will look at timeline analysis. Timeline analysis is a method of analyzing the data in chronological order using the time data included in the analysis data. Timeline is also used in our everyday life. A typical example is Facebook. When you look at the Facebook user page, what the users write is often called a timeline by the user. The timeline concept is not unfamiliar to us. This is originated from the forensic analysis. So, why do we do timeline analysis? Artifacts have their own meaning, so why not just select the artifacts you need and analyze them? Analyzing artifacts individually is easy, but it is not easy to understand the overall situation. Timeline analysis is often used to understand the overall situation. Nowadays, it is very important to understand the whole situation due to APT attack, target attack, and so on. For this reason, timeline analysis is one of the analytical processes that cannot be excluded in the analysis of infringement. And by analyzing the timeline, you can easily see what happened before or after a certain time. It also provides insight into artifacts that analysts do not understand, and it is necessary analysis in many ways. There are a few important factors in the timeline analysis. All of the factors in the lecture material are necessary for timeline analysis, but the most important factor is reliability. Other factors can also be trusted by having confidence that the time value has not changed. There are two methods of analysis, whether you know the specific point in time or you do not know. If you know a specific point in time, you can analyze the point in time before and after data in the timeline data. However, if you do not know a certain point in time, it is not easy to analyze from time to time. At this point, you need to analyze based on the nature of the incident or on the artifacts that need to be analyzed according to the analysis subject. Analysts need a lot of capacity when analyzing artifacts. The analyst's know-how or knowledge about the artifact analysis is required. Depending on the type of incident, the artifacts you need to look at may be similar or different, but the criterion for what artifacts to see must be created by the analyst himself. So, what tools are used for timeline analysis? The tools for listing and analyzing time values in file system metadata are the common forensic tools we know of EnCase, FTK, and X-Way Forensics. However, the time values we need to analyze do not exist only in the file system. Because it exists in most of the data called artifacts, you need a tool to analyze the artifacts in an integrated way. Plazo is developed for this purpose. Plazo, which is now being developed by the Google Forensics team, automates everything from data acquisition to analysis and timeline generation for analysis. In addition, memory analysis tools support timeline analysis targeting memory. This is the timeline table of EnCase Forensic Tool. At a glance, you can see how much activity has occurred for each day. There is one difficulty with timeline analysis. The structure and the information of the data to be analyzed are all different. You need to integrate this information for timeline analysis. The data types of the artifacts that contain the data also vary from text to binary, encrypted data, and so on. In order to integrate this, Plazo has created a separate analysis module. Plazo has formalized different data items. Formalized items range from time values, which are essential for timeline analysis, to artifact brief descriptions. Please refer to the lecture materials for details. The lecture materials you are currently viewing are timeline data. I will explain each item. The data_time entry is the time value extracted from the artifact. Time zone is a piece of information that indicates when a time value is currently set. The value of time zone is entered directly when the user creates the timeline data. Since most of the time values in artifacts are UTC plus 0, you must generate a time value that takes into account the area where the event occurred. MACB is the meaning of the time value. M means that the value of the date_time field is the modification time. A means access time. C is a time value that is changed when metadata information is updated within the file system metadata time value, which is called changed record time. Finally, B means birth, which means generated time. Next, the source field indicates the type of artifact, registry, event log, web, and so on. The source type field indicates a more detailed form of the source field. Type represents a more detailed form in source type. Other items are exactly the same as the field names and their meanings, so explanation will be skipped. Because the timeline data we saw earlier is formalized, you can also display the color as you see it for certain actions, making it a little more convenient to analyze. SANS has released an Excel sheet that uses Excel macro to sort timeline data by color. If you analyze with Excel, you can analyze it by using many functions of Excel. However, if the data exceeds 200,000 lines, there is a phenomenon that the program cannot stay an Excel program. The data capacity continues to increase, and nowadays it shows the limits of analysis. This is an example of timeline analysis of spear phishing cases. First, after receiving your spear phishing email, you can click on the link in the email body to see the clicked link in your Firefox web history. Logs redirected to a specific IP address are also visible in Firefox's web history. The Java applet runs and the trace is recorded locally. Malicious code is created and executed locally, and a pre-patch file is generated. Then you can see that the traces of the malicious code dropped are also found in various artifacts. By analyzing the timeline this way, you can see how things happened in chronological order by consolidating multiple data. When you identify these actions related to the incident, you will be able to judge the overall situation. Plazo is one of the timeline analysis tools. Previously, there was a Log2 timeline and Plazo was redeveloped as an open-source tool based on Python. Key features include image file parsing, volume shadow parsing, tags, filters, selective collection, and many more. The material you are looking at is the structure of the Plazo tool. Plazo first executes pre-processing. It identifies whether the input data is an image file, a folder, or a local volume, and identifies the operating system and what the user list is. Once you obtain all the information needed to create timeline data in this way, it passes the input data to the worker. Worker is in the process of generating timeline data. By default, a total of 6 workers runs simultaneously. The number can be specified the user as an option. The collector will also run with the worker simultaneously. A collector is the process by which it collects data to be analyzed by worker. The analyzed data is saved as a file in a file structure created separately by Plazo. This is called a storage file. The user then uses this storage file to change the timeline data to the file format of his choice. This is a page that summarizes the contents described above. The Plazo tool supports 5 tools that allow users to perform multiple tasks. Let's look at each one. The image_export tool is a tool that allows you to selectively extract files from your analysis target. The Log2 timeline.exe tool is a tool that handles artifacts in the analysis to create separate storage files. It is a tool that generates data for timeline analysis. The pinfo.exe tool is a tool for viewing a variety of information stored in a storage file. You can see progress of which artifacts have been analyzed, tagging, and error information. The preg.exe tool is a tool used to analyze Windows registry. Finally, the psort.exe tool is a tool for sorting timeline data stored in storage files. In addition, the user can change the timeline data to the desired output format. Here is how to analyze with Plazo for your reference. The image_export tool allows you to selectively collect artifacts from your analysis, and it supports a great number of options. Image_export extracts the path, file name, extension, and so on that match the value entered in the analysis target. If you enter a time range, it also analyzes the file system metadata and extracts everything in the time range. If you enter a unique signature for the file, the extraction will proceed as well, except for the most commonly known signatures. File format signatures used by certain software are not applicable. The log2timeline tool generates timeline data and stores the generated data in a file in storage. You must enter the necessary data to generate timeline data. You must first enter the time zone. Most artifact data has a time value of UTC plus 0. Therefore, you need to include the time in the region where the incident occurred to analyze the incident correctly. Next is the storage file path and name. You must enter the storage information to store the generated data so that you can check the timeline data. Next, you need to enter the analysis target from which to import the timeline data. The status_view option is listed as a required option in the lecture material, but it is not mandatory because the tool will run without actually giving the option. However, creating timeline data takes a very long time. Therefore, you can identify the situation in which timeline data is generated by entering that option. The log2timeline tool can be used to input three types of analysis objects: raw image file, E01 image file, volume or folder type. E01 type, volume or folder type is not problematic to run the tool if you enter only the mandatory options mentioned above, but raw type image file cannot be analyzed until the start sector of volume is input. The starting sector input for the volume is the 0O option. Identification of the starting sector of the volume must be determined by the analyst and entered. Now let's look at how to use the log2timeline tool to generate optional timeline data. Creating timeline data with all the data stored in the analysis target takes a long time, so the log2timeline tool supports the ability to create timeline for only the data you want to create. Use the -f option to specify the path to the file you want to generate timeline data for. However, you must specify the path to the file in a text file, and the path to the file must be one line. The pinfo tool verifies the information in the storage file created by the log2timeline tool. Even if you enter only the storage file without any options, the tool will interpret the storage file and display the information in the storage file. Preg tool is a Windows registry analysis tool. The analysis target is the Windows registry file and the image file. The -C option will work in console mode. Console mode is a mode for analyzing the registry like how you would type information at the command prompt. For detailed console mode commands, please refer to the tool's help. The psort tool is a tool for sorting timeline data and outputting the data in the format you want. It also provides additional analysis functions. There are precautions when using psort tool. You must enter the same time zone option that you entered when using the log2timeline tool in the psort tool. Other options that you must enter are the storage file path, the output format, and the path to the file to be created in the specified format. Rest of the options are not mandatory. The psort tool supports automatic analysis. Automatic analysis is not a required option. However, it is a very good feature that will help your analysis. There are several automatic analysis functions. Among them, the tagging function is the most used and it is very helpful for analysis. Tagging of the psort tool is a feature that displays the information that each artifact has. To use the tagging function, you need a text file in which the tagging information is written. Basic tagging information is supported by the Plazo project. If you go to the Plazo GitHub page, there is a text tagging file. The file can be used without modification, or the user can add tagging information at will. Tagging target storage files. Therefore, you can use the Pinfo tool to check the tagging information. The psort tool supports about 10 output formats. However, 3 output types can be used only by installing a separate module. The most common output formats are SQLite and CSV. There are a lot of timeline data, formats that can handle a lot of data more easily than other formats are used. As development continues, it is expected that Elastic and TimeSketch formats will be used as well. Elastic refers to the Elasticsearch format. As Elasticsearch is a big data search engine, it is well suited for handling large amounts of data. However, it takes time and effort to build Elasticsearch. To solve this problem, a search engine called TimeSketch is being developed via Plazo project. Plazo is a web search engine for quickly and easily searching data. Because it is made only for Plazo, it is optimized for Plazo rather than Elasticsearch. However, since it is still in development, it is not ready for immediate use. The psort tool can sort only the data stored in the storage file by matching the time conditions. This is done using the -slice option. If you specify a time and enter slice_size, only the data before and after the specified time will be extracted. The default value for slice_size is 5 minutes. You can use the filter function in the psort tool just like the log2 timeline tool. Filters are based on time values. If you enter a filter syntax using a comparison expression, only the timeline data matching the condition is output. Please refer to the lecture materials for the filter syntax.